So we thank you for coming to hear this unknown person and to listen to what I have to say. It looks like we're going to get a big broadcast somewhere if anyone wants to pick it up on the web at a future date. I've now been in the education business since 1981 when I joined Auburn University. Prior to that, I worked at the Hanford site for Westinghouse Hanford Company and the Department of Energy in Germantown, Maryland. So if you count the number of years that I've been out of school and sort of in the business, we're somewhere over 40 years at the present time. However, I've looked back upon the education part of the career, and it has, of course, been very good to me, and I'm also most excited about education, and particularly the future of welding education. I'm here to talk to you today about the future of university welding education, and this is my personal view of where things are going. As you will see, there are changes that have occurred and continue to occur, and these changes are principally driven by funding and incentives which are given to the workers and to the faculty which are involved in the educational process. I've listed what I believe are the factors currently influencing welding education. Principally amongst the factors is the changes in funding patterns. When I started in 1981 at Auburn University, there was only one job and one job only, and that was teaching classes. I was assigned to 6 to 7 courses per semester. What that meant is that we were in class most of the time. And in those days, if you recall, things were done by chalkboard. And so the lecture room would be about this size. There would be somewhere between 45 to 50 students. That would be the average size class. And I'd start writing on that wall with the chalk. And by the time the 55 minutes were done, I'd be ending up writing on that chalkboard. That has changed dramatically because of technology and because of funding patterns. The second influence upon education, and I believe these influences all levels of education, from the skill schools all the way up to university education, are incentives. What do the administrators expect of the faculty? What do they set as being the goals of the faculty that will cause the process of education to change and also determine what type of student is produced? These days we have global competition as seen by what is happening here right now. You can videotape and it can be on the web instantaneously or distributed by CDs or downloaded anywhere in the world very rapidly and very quickly. There also have been revolutionary changes in technology which have not only affected our daily lives but immensely changed how we teach or how we educate and how the student perceives what we are presenting to them. And finally, but not least, are the evolving standards of education. I will talk about things in the reverse order, going from evolving standards for education and then coming back to changes in funding pattern for this discussion. Now, at the university level, there's what is known as the Accreditation Board for Engineering and Technology, ABET. Basically, it was founded in 1932, and there are approximately 3,100 accredited programs at 600 universities and colleges, not just in the United States, but now worldwide, which are accredited. Okay? I work at Auburn University and do welding education in the materials engineering program. And the Auburn University Materials Engineering Program has been accredited since the 1960s. When I first started this job, as I was indicating by the chalkboard back in the 80s, accreditation was a matter of counting the number of credits that the student would get in their education program when that degree was awarded. So the accreditors would come in, or the accreditation team would come in and ask, how many classes in science and mathematics did they get? How many classes in statistics did they get? How many classes in calculus did they get? How many classes in chemistry? How many classes in physics? And would count up the hours and see whether this matched their so-called accreditation standard. It's a very rigid standard, okay? So that in order to be acceptable, you had to have so many math, so many science, and so many engineering credits, and there was very little to argue about. What this tended to do is to force all programs into the same box, so that programs dealing with welding of steels versus, let's say, joining of ceramics, all had to meet the same criteria. And so there wasn't really the independence or the focus on doing what you were best at your institution. It was a matter of meeting the general requirements. During the 1980s, this rigid evaluation started to change. We had the Challenger disaster. And people started talking about, hey, we're producing engineers that may know everything science and engineering wise, but they have no idea about professionalism in the workplace. When do you have to challenge your boss? When do you have to stand up and say, this is wrong? That's when they began to put into the classes what we call, or into the accreditation requirements, what we call professionalism. How to handle different situations, how to make sure that you don't use inches versus millimeters when things have been designed in millimeters. So we began to emphasize quality assurance. We began to emphasize what we would call soft engineering, but things that make right for decisions. During the 1990s, requirements emphasizing design and ethics were added. It was realized that the way we were teaching was very strict. In other words, when we gave a problem or a test on examination, there was only one answer. And that's not the way that engineering problems are. There are usually infinite number of answers, although there may be one better answer. Or should I say, most often there is one better answer. But there might be an infinite number of solutions to the problem. And so the emphasis began to change, and we were talking about design. Then we got into ethics. When you have designing a backup vehicle, you need to have a buzzer on it to warn people that it's backing up. We got into litigation. Failure analysis was emphasized during this particular point in time. But the whole ideal is that the requirements for education were changing, okay, from an emphasis on hard science and engineering to professionalism, ethics, manufacturing standards, and a whole bunch of other things that are required of our engineers today. In the 2000s, something happened. We got what is known as EC 2000. And in the EC 2000, this was the most dramatic change that we had had since the 70s and the 80s. What we now began to ask ourselves is, who were our customers? Were our customers our students? Were the customers their parents? Were the customers the industry? And instead of just how many things did we teach them in class or did we present to them in class, what did they learn in class? So things are now based upon outcomes rather than your teaching. You may present everything in the book to them, but whether they learn it or not depends upon outcomes, okay? And so we now evaluate by what is known as outcomes. And because of this, programs were now allowed to basically tailor their engineering content so that programs can have individuality. For instance, in the state of Alabama, if someone wants to do metallurgy, the University of Alabama, Tuscaloosa, is probably the place to go. If they want to do material science and engineering, then my institution, Auburn University, is probably the place to go. If they want to emphasize medical sciences, materials for medical applications, then the University of Alabama, Birmingham, with the medical school, is probably the place to go. So this allowed programs to individually tailor their education for their audiences and be different, yet have a uniform standard for accreditation. I shouldn't say uniform, but still have a standard for accreditation. Lately, people have begun to realize that no matter how many credit hours we have, how many class hours we have with the students, we are not able to teach them enough. Technology is changing, so the minute they hit the ground in their business, what they have learned is probably outdated. So we now teach how to learn, which is the subject of lifelong learning. So, as you can see, the standards for education have changed dramatically during the short time that I have been in the business, and I'm sure that they will continue to change. Now, I should say that each university has addressed these accreditation changes in a different methodology. What some universities have tried to do is to utilize all the latest information technology to speed up and to present the students with everything that is required. Of course, background and detailed information has been reduced in many cases. For instance, no longer do we give drafting classes. In the 80s, when I started, drafting was a big deal. You had to go out there and sit down at the table, sharpen your pencil, and draw a straight line. At that same time, we had Fortran computer classes. No one does that anymore. Machine shop skills. We had every student go in there and do lathe work, milling machine work, grinding work, welding work. Everyone, every engineer was subjected to shop classes. Those have long since disappeared. There's been a reduction in laboratories. With the advent of the computer, most laboratories can be simulated. When I was first teaching in the 1980s, one of the classes that all our students whether they be welding engineers or materials engineers or mechanical engineers, they had to go through thermodynamics, what was called engineering thermodynamics. And one of the laboratories in engineering thermodynamics was to start up a boiler, run it, and produce power. That has long since disappeared. You can imagine back in the 80s, we didn't have air conditioning in classes at that time. My class was right above the boiler room. Students were downstairs running the boiler, you know, letting off the steam. Steam was coming up through the floorboards, making the room unbearable in the class above. Now we run that class by simulating the operation of a power plant on a computer, okay? Same thing, you know, we teach engineering thermodynamics with steam tables and with computer simulations and computer classes. Many things we now assume that the student knows when they come to us. Things such as Microsoft Word, PowerPoint, and Excel, even Microsoft Project, the scheduling software, and even basic computer-aided design and manufacturing programs such as Solid Edge. We assume that the student will learn and will know prior to his getting to the class or learn during class. The whole new generation is very adept at self-learning with computer programs. And so those things, while we used to have to teach drafting and Fortran and machine shop skills, we now expect the students to come in with those proficiencies. We had a reduction, particularly in laboratories which deal directly with welding. We used to have one course which would cover all the non-destructive testing of welding. Ultrasonics, mag particle, radiography, helium leak checks. We would spend a whole quarter with 12 laboratories, each of the laboratories being 3 to 4 hours apiece, doing non-destructive testing. We used to have a weld processing laboratory where we would go through each one of the techniques and the students would do stick, MIG, TIG, sub-arc, and do all the processes. No more. And I'll explain the reason why in a minute. We used to have extraction metallurgy, steelmaking processes, injection molding, protrusion. All these manufacturing processes of materials also in the laboratories. No longer do we have the option to do so many laboratories. Today's graduates are by far much more ready for the business place in terms of ethics, law, statistics, economics, and environment. They know what to do. They know how to handle pollution. They know OSHA standards. Our graduates are capable of forming engineering recommendations for situations with many solutions, so they can list pros and cons. They can give what is a better answer, not the only answer. And they can give you more than one or two options and then recommend one option. Engineers of 30 years ago, when we graduated them, they always would think that there's only one answer to the problem, and that's whatever the equation said, and that's the answer that came out. Graduates today are capable of learning and adapting on the job. Lifelong learning has made the students much more capable to go in and to tackle difficult and hard problems. Graduates graduate with less specific knowledge. That's not quite correct. I should say with less hands-on of processes, but they are better equipped for today's employment. I firmly believe that the students of today are much more capable of going out and immediately fitting into the workplace and being assured of contributing right off from the bat. So those are some of the effects of the evolving education standards. Effects of technology are just tremendous. That's what we taught in the 70s. Of course, today, everything is on a handheld computer, which makes things speed up a lot. If you recall, every time we had to talk about diffusion of a weld, we had to go back and explain the error function, look up error functions in a table, explain how to use the mathematical handbook where the tables were located. Today, basically, all we have to do is specify you use the error function, explain to them what the error function is in terms of how it was found and how it's used appropriately, and a handheld device can now go ahead and do that. Steam tables, integration, complex algebra, graphing. We no longer have to take out semi-log paper and log paper and have the students graph out each individual point to figure out whether it's a logarithmic function or a semi-log function. All of it can be done on a graphic calculator. So that has helped us tremendously in being able to cover much more of the technical information that we need to make sure the student knows. There is a downside to that, though. Oftentimes the students really don't understand what an error function is, although they know how to use it. Another biggie, when I started out, everything was done by graphic lettering. You know, if you had a paper and you wanted a graph, you had to get out the ink and the graphic lettering equipment. Letter your graphs. These days, a personal computer replaces the dedicated word processor, which you had to have an expert do, and even replaces the graphics department, where we had probably 10 people doing the things that one can do on a personal computer. So we've basically, by technology, replaced a large number of people, reduced the amount of time that is required to get things done, and it's correct. Because the faculty member or the student, the author, knows what he wants, and he doesn't have to go through the many sequences of interpretation with non-technical trained people. So not only has it helped us, but reduced time, but it's also made it much reduced errors, much more error-free. Publications, books, and tests now can be prepared on the spot. Libraries, well, this is a biggie at Auburn University. In the 1980s, the library said, in order to be a #1 university, we have to have tens of thousands of square feet so we can store our books. Guess what? Along comes digital storage, and now you go in the library, it's 3/4 empty. Because everything now is digital. We can access any of the books, any technical publications within the last 25 years digitally from anywhere on the campus. Wi-Fi exists everywhere, so all you have to do is pull out your iPad. Okay, you don't even need a portable computer these days. Pull out your iPad, go to the library, say you want to see this article. That article appears on your iPad and you can read it directly. Any video can be uploaded or recorded in any room on the university campus and can be distributed worldwide. So I have students in China watching some of my lectures simultaneously. At no cost. Okay? The internet, wireless, free, I should say not no cost, but very, very low cost. So technology has changed what we do at the university dramatically. Here's what I used to use. The ditto machine, you know, put that fluid down there, write the thing down, and then for the test, and then maybe I'd get 20 copies out of a ditto master. If I needed more than 20 copies, I had to do it again. You know, the copier has made this thing obsolete. But even now, the copier is obsolete. Everything's electronic, so with your iPad, you can see it, and you can read it, and you can store it, and you can pick it up anywhere. I shouldn't say every, but almost every lecture room and laboratory is now connected with what we call electronic smart boards. So my presentation, I can do it in my office, typically use PowerPoint. I can go to class, and I don't even have to have a computer with me. All I have to do is automatically tell it where it's located on the internet. It'll pull up my presentation from the internet, and off I go lecturing in class. Now, because of that, and because I can put all the information down on a PowerPoint slide, we can go through 10 weeks of material, if we wanted to, in approximately 3 weeks. Okay, because no longer do we have to write, no longer do we have to erase the chalkboard, it's there. And you ask, how do the students learn it? How can they absorb so much? You have to have good analogies as to how this is used and what it applies to. But remember that all the stuff is electronically stored. So the student no longer has to take notes. Basically, he pulls up the lecture and he has all the notes. And so he's able to refer to them at any point in time, any place that he may need to. Okay, the wired student. I have students which come to class like that, and they sit through class totally like that. My lectures go into a podcast. The podcast goes wirelessly out to her. She's listening in class on her earbuds, plus watching, depending upon what type of device she's got, whether it be an iPad or an iPhone, the actual video which is ongoing. Now, not all classes are like that, but many are. The students appear to be always wired. Many of them won't attend classes. They receive the instruction by Wi-Fi anywhere on the campus using the video podcast. They submit all their homework and tests via electronic means. And if they have questions, I will get a FaceTime call. If you know what FaceTime is, basically it's an actual video conference using an iPad or iPhone from that student. And anywhere on campus, any place that's Wi-Fi, Starbucks, they can find me. And oftentimes I will get calls, even when I'm at the meeting, asking for a video conference to discuss some presentation I've made. So it's wherever, whenever means of education these days. Now, funding is the most important effect upon how things have changed. In 1980, for our group, and I know this since I've been the chairman of materials engineering, I can go back and look at the records. For the materials engineering group at Auburn University, this is the breakout of where the funds came from in 1980. 1980, we got about 82% of our funding from the state. 11% from federal contracts, 4% from corporate contracts, and about 3% from gifts. The primary objective of the state was to do what? Fund higher education to produce bachelor's degrees. Right on the board, 55 minutes, all the way around, educate the student. In 2010, as you can see, the state funding of our group has been reduced dramatically. It's now only 57%, with 30% coming from federal and institutional research grants. 10% coming from corporate grants and 3% coming from gifts. So we haven't had much change in alumni donating back. It's about the same. But the federal share and the corporate shares have increased dramatically, while the state shares in education funding have been drastically reduced. So what does this mean? How does it affect things? No longer are we being paid to educate individual bachelors of science or bachelors of engineering degree students. Most of our funding, or almost 50% of our funding, is now coming, requiring us to do other things. Back in the old days, faculty members were 9-month employees or even 12-month employees, and we taught. We taught 6 classes every quarter. Nowadays, all our faculty members are required to pay through external contracts 4 months of their 12-month salary. State funding for our program has been gradually reduced to 55% of the annual budget. In 1980, we had an accountant, we had an administrative assistant, we had 2 laboratory technicians, all funded by state funds in support of the education mission. Today, we only have 1/3 of an administrative assistant supported by state educational funds. All graduate students, postdocs, visiting postdoc salaries are now paid through what we call externally funded research grants. In the past, we've had graduate teaching assistances, which are funded by the state to help us meet the teaching mission. That no longer exists. So you ask, because of these reductions or changes, what is happening to the overall science advancements in the United States in welding? What I did is to try to get a handle on this between the years 1995 and 1999 versus 10 years later, 2005 to 2009. I went into what is known as citation abstracts. Went to Engineering Index and basically asked for it to identify all articles on welding, joining, brazing areas. I then asked the computer to classify these things by region across the world. So US and Canada, that's pretty clear. Asia, Europe, former USSR. That's probably not a good technology, but that's terminology. But that's something that I remember. And then others. If you take a look at just the publications in the United States leads every other world country by far still in terms of the number of publications. However, by region, the Asian region and the European regions have changed somewhat. As you can see, US and Canada has dropped from 29% down to 23%, while the Asian group has come up from 19% of the total to 27%. That's not just China, but it's Korea, it's Taiwan, it's Singapore. All of them combined, there is a lot more research in the area of welding and joining going on in those countries than 10 years earlier. So there is a global change in what is happening in terms of publications and research in the area of welding and joining. I like to describe the welding education system as being a three-tiered system with universities and colleges on top, producing PhD, MS, and BS degrees. Community colleges, which are now producing BS, associate, and possible certification in the welding area. And then what I call the real backbone of skill training, the not-for-profit Welding Institute and private trade schools, where certification, most of the certification gets done. This is my feelings as to where things have changed and where things are going over the past 30 years. Universities, colleges, because of the funding change from state-funded education to external research contract-funded work, the emphasis has become on research funding. And particularly, the system is favoring PhD and postdocs. Many programs no longer accepting master's degree students. Bachelor students are still a mainstay of colleges and universities because of that state mandate. The BS degree programs have been collapsed into the most popular areas. As I had indicated, welding is welding classes, such as the non-destructive classes, the welding processes classes. Even though those classes still exist on our books, we do not get enough demand for them to offer them very often. The reason being is because the students do not have that many technical electives anymore. Because of the rise in technology, the need to teach that technology, most of their classes are fixed in terms of what they can take. And so, therefore, the real specialty classes, such as non-destructive testing, welding processes, are taught less and less frequently. Community colleges, reductions in budgets for workforce development are occurring all across the community colleges. It's too expensive to maintain specialized machine shop, welding, and NDT courses. So what they're emphasizing right now is the BS degree in liberal arts. Okay? We're losing our workforce development. They find that they get a greater financial return offering higher enrollment in college prep classes. So in our particular area, which is really booming in workforce development, Alabama, Kia, and Honda being two major automotive manufacturers, and then all the first and second tier suppliers, it's just tremendous amount of jobs that are needed with workforce development. Unless that company comes in and partners with a community college for that workforce development, they're finding it too hard, too costly to fund workforce development. So even at the community college level in our area, workforce development is, funding for workforce development is being decreased. This leaves and makes very important what the skill-oriented organization's doing most important for the future. Some of the leaders in this area are and must be for the future Hobart Institute of Welding, Lincoln Electric Welding School, Skills USA, as we were talked about this morning, and all the other skill-oriented education institutes across the United States. I've listed just a few up here, and I don't mean to be at all ignoring anyone. The list is absolutely not inclusive. Andre Odermatt of Hobart Institute of Welding Technology provided me some numbers, which I have interpreted. Okay? What we see is over the last decade is that, as I would anticipate, their enrollment has increased. There are quite a number of government and programs which allow the students to receive funding while they go to school and then pay back. But even with this increase, I don't think that there are enough skilled workers being produced. I tried to analyze Andre's data that he provided me with to identify what students wanted to take these days, see whether there was a shift in what they were emphasizing. And there is. There's a lot more demand for basic knowledge of the welding process, weldability of metals, just that class. And this is the percentage of the class. Remember that the total enrollment's increasing, so what I've done is normalized everything, so this is the percentage of that increasing enrollment to sort of give you the trends. The other thing we see is that CWI, prep, is a very popular class. And of course, that makes sense because it is, since they've started doing CWI, it really puts money into the pocket of the person who becomes certified. Okay, and as you can see, demand for other courses sort of is down in this range, but two stick out. And I thank the Hobart Institute of Welding Technology for this information. So the first thing that I want to emphasize is that because of funding trends, the emphasis of the college, universities, and community colleges is switching, in my belief. We're going to have to, in the future, rely upon the skill schools to produce the workers that we need. So they are a very important leg of the three-tiered stool that the workforce development for welding sits upon. Universities and colleges are increasing emphasis on PhD and postdoctoral research. That's because our administration tells us that we've got to get more external funding. We cannot rely upon state funding any longer. And when we get a research contract, we have to produce the research. And spending 2 years, in which 1 year is spent on educating a master's student and 1 year is spent on performing on the contract, just doesn't pay. Versus a PhD student, which you spend 1 or 2 years training and he's there for 5 or 6 years. I believe that community colleges are downsizing their workforce training programs because of financial problems. It doesn't pay. It costs too much to have the new welders, to have a certified CWI as an instructor, versus a BS degree or a master's degree liberal arts person teaching English or college prep courses. And so I really feel that welding education relies or depends upon our skill training institutes. That's one person's view of where we're headed and what has been happening for the last 30 years. I now open the floor for questions. Oh, I have two other things here. In 1981, in memory of, I gave a final examination. And I allowed all the students to come in with 4 pencils, and of course a Scantron chart. This student attracted my attention immediately because he wanted to borrow a pencil from someone else because none of his pencils were sharpened. And he'd written all the answers on the outside of the pencil, scotch taped them so they wouldn't smear. And so no longer do we have to deal with that problem or that type of cheating in class. It's all different these days. And this is one of the photographs that they took in 1981 of welding education. How many OSHA violations do you see there? Probably at least I could identify 4 or 5 immediately. Well, I thank you very much for your time. And I guess I owe everyone here a fee for attending my lecture. Thank you very much. Have a good day.